Hi students, I am Ranjit and I am a faculty of Mechanical Engineering Department FISAT, and today I am going to start a course on calculus because it's an essential skill to learn calculus for engineering students. Not only for engineering, all the science subjects and some commerce also, it requires a basic understanding of calculus. Because most of the time what will happen, because the students will learn calculus but they will learn the process, they are not focusing on the physical meaning of that processes. That becomes very difficult to learn the later subjects, and especially if you take the case of mechanical engineering, and there are some subjects, so called difficult subjects like advanced mechanics of solid, fluid mechanics and heat and mass transfer. All these subjects, it's all the derivations, and mainly these subjects are made with the help of calculus, and all the derivations are based on calculus. So it becomes very difficult if you only learn the process. So what's my aim or my objective for this course is that I will give you an introduction to what is the physical meaning of calculus. Simple thing, in a simple words, if you write a differential or integral equation, what is its physical meaning, why we are using it, or what we are doing with these equations. That's about my course, and welcome to the world of calculus, and we will learn it together. We will start our class with the concept of variables. What is variable? I will give you 2 seconds to think about that. Okay, variable is something which occupies various values. If you take an engineering case, a pipe flow, variable can be mass flow rate, or the velocity of the fluid, or the pressure of the fluid, or the rotation of the valve. Anything can be a variable because it varies with respect to time and space. Generally in engineering we will consider 2 variations. One is called as a temporal variation, the second is called as a spatial variation. Don't confuse these words, because temporal variation means that there will be some variation with respect to time. Because if you switch on air conditioner, the room temperature is going to reduce. It is with respect to time, because if you measure at the initial time, the temperature will be the ambient temperature, and if you measure after 10 minutes, the temperature will be lower than ambient conditions. That means the temperature is reducing with respect to time, so you can take it as a variable. Similarly, the pressure in a pump, when you start the pump or when you change the pump speed, its pressure is going to vary. So these variations we will represent it with the help of variables, and in mathematics we will call these variables, or we will classify these variables into 2 categories. One is called as a dependent variable, the other is called as an independent variable. It's actually a confusing word, but don't worry about that. You can consider something like especially in the case of engineering analysis, you can consider the independent variables in a way that it's input variables, and dependent variable as the output variables. Let's take an example, a pipe flow. This is a pipe and there is a valve. Pardon for my drawing skills. Okay, and water is flowing through this pipe, and there is a valve, and I'm going to take 2 variables. One is the mass flowing through this area, and the other is theta. So theta is the rotation of this handle, because when you open it, that means when you rotate this valve, it's going to open and it will allow more amount of water to flow through this valve, and if you reverse it, that is if you rotate it in the opposite direction, it will close it. So the theta has definitely an influence on mass. So these 2 are my variables, one is theta and the other is mass. You can consider m is the dependent variable and theta is the independent variable. Because why I am saying m is the independent variable, because it depends upon the theta, because if you rotate, if you change the theta, m is going to vary. So there is a relationship between m and theta is considered as independent variable. Why? Because we are controlling it, the system. If you take this as my system, the system does not have any control on this theta. Theta is controlled by some other things or the other entity. So that's why it is considered as independent variable. And you can write theta is proportional to, sorry, not theta, the mass is proportional to theta, And this thing mathematically, in pure mathematical sense, you can reverse it and you can say theta is proportional to mass, but if you look into the physical process, you can definitely understand theta is independent variable. So that's a way we will identify what is which one is the dependent variable, which one is the independent variable. And if you know the relationship, the things the job is done, because it's an easy procedure to find out find out the mass with respect to theta. And the ultimate aim, or if you consider this example, the ultimate aim is to find out how much mass is flowing through this area for a particular theta. That will be our aim. And in order to find out that, first we will create a differential equation, that is dm by d theta. Its meaning is that there is a small change in mass due to small change in theta. The small change is called as dm and the small change is called as theta. What is this dm and d theta? Because if you take mass, or let us take another example that will be simple for understanding. So if x is a line, or you can consider x is the length of this line, this is the length of this line, and dx is a small part of this line. Okay, it's a very, very, very small, it's a teeny weeny, a small part of this x, that is dx. So what is this x? If you add all these dx's, or you can consider x is made up of small parts like dx's. So if you add all these dx's, you will get x. And mathematicians, they will say it's an element of, so don't confuse with that word, because element of, which means if this is actually a small part of the total thing. If dm is a representation of a small part of the total mass, or d theta is the representation of a small angular inclination or small turn when you compare with the total theta. So that is dm and d theta. And why we are taking this dm and d theta? Because it's merely a ratio, which means a small change in mass flow rate due to a small change in theta. So this is a ratio, and if you know this ratio, maybe that ratio can be a constant, can be an equation or anything, because we only know that mass is proportional to theta. If you write dm by d theta, that must be a function of theta. So we need our ultimate aim is to find out what is this function, because if we know this function, it's an easy business to find out the mass flow with respect to theta. So this can be a linear relationship, or a curvilinear relationship, or a sinusoidal relationship, or an exponential or logarithmic, whatever relationship is there. There is a function, and which is actually a ratio between these two variables. Hope you understand the concept. Next we will discuss about this the differentials and integrals, and that is in the next session. There are two symbols which terrifies most of the students when learn calculus. The same also terrifies me when I was learning the calculus during my pre-degree time. The first symbol, it is the D symbol, which represents the differentiation, and the second symbol, it's merely a long S, that is integration symbol. So these two symbols are very terrible because when we see this symbol, our mind trembling. So we are going to do some complex mathematical operations. That's the problem. So it's actually a simple concept, because as I already explained, if x is the line's length, suppose this is the length of the line, this x, and it's made up of small little bits of dx's, that is dx is a small part of x, or a little bit of x, and you can consider this line is made up of made with a lot of dx's, small little bits of x. And if we write this dx here, its meaning is that you are going to add all these little bits, and if you add all these little bits, what you will get? You will get x. So that's the meaning of integration. You are going to add these small little bits. So integral dx is equal to x, which means you are adding the small dx's, and you will finally get the total x. So differentiation means if you write dx, which means it's a small part of this one, that is if x is the line's length, dx is equal to a little bit of this x. And you can consider, if you take the example of time, you can see 1 hour is equal to 3600 seconds, and this 1 second you can consider it as dt. If t is equal to time equal to 1 hour, then you can consider dt equal to 1 second. So we can change this, we can take a dt equal to 0.1 second or nanosecond, that's your choice, but it's actually a small portion of this time. That is the concept, and if you add all these dt's, you will get the time, the total time. That is the concept of integration and differentiation. Next time when you see this symbol, you must understand you are going to perform some mathematical operations. You don't have to worry about these symbols, it's simple mathematical operations.